Our lesson today will be about price elasticity of demand. Elasticity in general allows us to measure the extent to which one variable is affected by another variable. When these two variables are quantity demanded and price, we call it price elasticity of demand. We previously know from the law of demand that when the price increases, quantity demanded decreases and vice versa, but we don't know to what extent. Price elasticity of demand allows us to answer this question. It measures the responsiveness of quantity demanded relative to changes in price. This is measured using a coefficient ED, which refers to elasticity of demand. It's a number. It represents the ratio of the two percentage changes between quantity demanded and price. Let's take a direct example on the formula of price elasticity of demand. A computer seller raises the price by 10%. As a result, quantity demanded for the computer falls by 20%. Calculate price elasticity of demand. Now, if we plug the numbers into the formula, you will notice that what we will have is percentage change in quantity demanded over percentage change in price. That is 20% over 10%, which is equal to 2. This translates into, for every 10% change in price, there's a bigger change, which is 20% in quantity demanded. Of course, according to the law of demand, we know that when the price increases, quantity demanded decreases and vice versa. You expect in such a situation that elasticity of demand would be negative since they're moving in opposite directions. But the fact is, for simplification purposes, we always take the numbers in absolute value, meaning regardless of whether there's a negative sign in the numerator or denominator, it's always the absolute value of the number, meaning elasticity of demand is always positive. Let's take another example on calculating price elasticity of demand. This time it's a more detailed one. If the price of a good changes from 12 to 10, its quantity demanded changes from 50 to 100. Calculate the price elasticity of demand. We can show this example graphically first. So we basically draw the coordinates of the 2 points, Q1 and Q2, and price 1 and price 2. We have A, its coordinates are price 1, which is 12, and quantity demanded 1, which is 50. And we have B with the coordinates price 2, 10, and quantity demanded 2, 100. From these points, we can draw the demand curve. Now, if we want to calculate the price elasticity of demand between the 2 points A and B, as we mentioned before, we're calculating for the midpoint between both. So elasticity of demand would be percentage change in quantity demanded over percentage change in price. Remember, we said we calculated an absolute value. So it's percentage change in quantity demanded over percentage change in price, and the answer would be 3.67. So the elasticity of demand of a midpoint between two coordinates, 2 points A and B, would be 3.67. Are elasticity and slope the same? Actually, they're not, but how can we prove it? Let's take demand in a table form. We have points A, B, and C, and we have the price and quantity demanded at each point. If we show it graphically, we have points A, B, and C, and we have the coordinates of each point according to the table. So here we have our demand curve. We all know that usually the slope of a straight line is constant. It doesn't change along a straight line, meaning if we're going to calculate the slope between A and B, it's going to be 10 minus 12 over 100 minus 50. That is negative 0.04, which is y2 minus y1 over x2 minus x1. This is how we calculate usually the slope of a straight line. Now, if we're calculating the elasticity of the midpoint between A and B, we know that the elasticity of the midpoint between A and B would be 50 over 75, which is percentage change in quantity demanded, which is quantity 2 minus quantity 1, 100 minus 50, over 100 plus 50 over 2, which is 75, over same thing for price, price 2 minus price 1. So between A and B, prices are, price 2 is 10 and price 1 is 12, so it's negative 2 over 11. So the answer would be 3.67. Okay, now let's calculate the slope between B and C. So the slope between B and C is y2 minus y1 over x2 minus x1, which is negative 0.04. So the slope along a straight line does not change, it's constant. Whereas elasticity between B and C would be 50 over 125, which is quantity demanded 2 minus quantity demanded 1 over quantity demanded 2 plus quantity demanded 1 over 2, which is 100 plus 150 over 2, that is 125, over P2 minus P1 over P1 plus P2 over 2. The answer would be 1.80. So notice that whereas the slope of a straight line does not change, the elasticity of demand along a straight line changes from one point to the other. So as you can see, elasticity between A and B is bigger than the elasticity between B and C. So we now know the formula for price elasticity of demand, and we know what elasticity is. But what are the different cases of demand elasticity? Demand can be elastic if elasticity is above 1. This case means that quantity demanded changes proportionately more than the price changes. Then we have a case of elasticity where it is less than 1. In this case, quantity demanded changes less than the price changes. We have another case where elasticity is equal to 1, where the change in price is followed by a change in quantity demanded in the exact same percentage. We have a case where demand is perfectly elastic, and in this case, quantity demanded is extremely responsive to even a small change in price. And the last one is the case when elasticity of demand is equal to 0. And in this case, even if the price changes, the quantity demanded does not change in any percentage. What results can we get while calculating price elasticity of demand? Demand can be elastic. That means elasticity is above 1. When do we get a result that is above 1? When the numerator is greater than the denominator. That means when the percentage change in quantity demanded is bigger than the percentage change in price. So here we notice, for example, in this example, when the price increases by 10%, quantity demanded decreases by 20%. So for every change in price, there's a bigger change in quantity demanded. So demand is elastic. You notice that the demand curve, although it's sloping downwards, it's slightly horizontal, reflecting the fact that demand is elastic. So here we can see, according to the formula, when the numerator is bigger than the denominator, or quantity demanded has changed a lot more than the change in price, demand would be elastic, it would be above 1. Here we have it's 2. So when would the demand for a good be or a service be elastic? In fact, the more the substitutes for a product or a service, the more elastic it is. So goods and services with elastic demand have a lot of substitutes, meaning when the price increases for this good or service, you immediately shift to the lower price substitutes because you have a lot of substitutes to use instead of the product. For example, if you usually buy burgers from McDonald's and the price of burgers at McDonald's increases, you shift to Hardee's or Burger King or any other burger place because you have many substitutes to resort to. Same thing applies for any other product which has substitutes. It can be furniture, motor vehicles, luxury cars, soft drinks, or any other product. So the more the substitutes, the more elastic demand is. Now, inelastic demand, which means elasticity of demand, which is less than 1, is another case of price elasticity of demand. This happens when the numerator is less than the denominator, meaning when the percentage change in quantity demanded is less than the percentage change in price. In a graphic form, we see that for a 10% increase in price, there's a 4% decrease in quantity demanded. That is less than the increase in price. So here, if we calculate it, we notice that the numerator, which is percentage change in quantity demanded, is less than the denominator, which is percentage change in price. So the answer for elasticity of demand would be 0.4, which is less than 1. Here we say that demand is inelastic. If we draw it graphically, we notice that although the demand curve is sloping downwards, it's slightly vertical, reflecting the fact that when the price increases, quantity demanded decreases by less. We've previously established before that goods which have a lot of substitutes have higher elasticity. Now here the opposite holds true. One would, even though the price of a good or service increase, yet quantity demanded does not drop much. When the good or service has fewer readily available substitutes. So that means even though the price increases, yet people don't give up much of it. So a price change does not affect the quantity demanded as dramatically as the elastic one. For example, eggs in the broad sense. We're not talking about the kinds of eggs. Or salt. If you don't put salt on your food, what would you put? Probably some of you would say, okay, we can put soya, we can put other things, but in fact, there are not many substitutes available for these products or cigarettes in the broad sense, not when we're talking about the kinds of cigarettes. So we say that demand is inelastic for products, goods, and services which have fewer readily available substitutes. So we have elastic demand, we have inelastic demand. Now here we have unit elastic demand. That is, elasticity is equal to 1. When would the result be equal to 1? When the numerator is equal to the denominator, meaning when the percentage change in quantity demanded is the same as the percentage change in price. Here, if we draw it graphically, you will notice that this is a perfect demand curve. So, for any increase in price, there's an equal decrease in quantity demanded. Here we see that a 10% increase in price will result in a 10% decrease in quantity demanded, which is the same change. So here, if we're going to calculate it, you notice that percentage change in quantity demanded is equal to the percentage change in price. Of course, this is a perfect case. Here we have 10% increase or change in quantity demanded and 10% in change in price. So here we have the result would be 1. We call it a unit elastic demand. Actually, it's very rare that you can encounter goods that have a unit elastic demand. It's very difficult to have the same exact change. It can be, for example, movies or tires or oysters or private education. But the fact still remains, even though there are examples, but the fact remains that it's very hard to get goods where a percentage change in price will result in the same exact change in quantity demanded. So we took elastic, inelastic demand, unit elastic demand, and now we're taking perfectly elastic demand, or elasticity is equal to infinity. This happens when a small change in price causes an extremely large percentage change in quantity demanded. Suppose, for example, someone would buy all units from a product at a price of $5, but if the price is 5.1, he'll buy nothing. So here we have the demand curve is, as you notice, it's horizontal, reflecting the fact that a small change will result in an extremely large change in quantity demanded that it's almost infinite. Of course, this is also a perfect case, which in reality. So what are the characteristics of goods which have a perfectly elastic demand? Usually these are the goods which take up a huge percentage of a person's income, and they have many substitutes. So if there's even a slightest change in price, it's going to be too much for you and you'll move to another substitute. For example, sports cars, which are really expensive, and you can buy another car instead. Suppose we're talking about McLaren and Ferrari, for example. So here we have, it's a huge share of the income and many substitutes available for the product. Let's move to another case of elasticity of demand. We've previously defined elasticity of demand as the extent to which quantity demanded changes in response to a change in price. When demand is perfectly elastic, elasticity of demand is equal to zero, meaning regardless of any change in price, quantity demanded is not affected, so the effect is zero. If we're going to show it graphically, you will notice here in this graphic representation that when the price increased from P1 to P2 by 10%, quantity demanded stayed the same at Q1. So at P1, quantity demanded is Q1. Then the price increased to P2, yet the quantity demanded remained at Q1. That is why you notice that the demand curve is vertical, reflecting the fact that there's no change in quantity demanded. If we're going to plug it into the formula, you will notice that since elasticity of demand is percentage change in quantity demanded over percentage change in price, and since there's no change in quantity demanded, so percentage change in quantity demanded is zero. So it's going to be zero over the change in price. So elasticity of demand is zero. These kinds of elasticities are usually in products which are necessities and you can do without. For example, if we're talking about heart medication or insulin, even if the price changes, you don't expect people to give up taking these kinds of medications because there are no substitutes and they are necessities. So elasticity here is equal to zero.